All right, so kernel debugging with WinDebug is the real point of it. So here's how user applications run in Windows. You have an application up here like Word or something that typically calls kernel32.dil, which is the normal Windows API to get to the kernel, which can reach the hardware. That then calls ntdil, which is the native API, which only Microsoft professionals are supposed to be using. And then that makes the jump to kernel mode. User mode code cannot touch the hardware. It can only execute certain subset of assembly language instructions. The kernel is the code that's allowed to access to all the instructions. And the only thing that's supposed to be in the kernel is code written by Microsoft and written by your device manufacturers, who are supposed to submit all their drivers to Microsoft to be verified before they go in there, because code in user land that crashes just puts up an error message and doesn't kill the system, but when the kernel crashes, your machine has the blue screen of death and dies, and that's a bad user experience. So Microsoft has learned to be very picky about what code is allowed to run in here. An NTOS kernel is the Windows kernel, and it connects to drivers and data structures about your hardware. So NTOS kernel is just a normal exe file, it's the kernel. You can open it in CFF Explorer, one of the many tools, and you can see its function calls it offers. It exports functions like ALPC, create security context, and so on. And you can use BCD edit to do local debugging on one machine. So in this case, all you can do is view the kernel. You cannot put a breakpoint in it, because if you put a breakpoint in the machine you're using, it will freeze and stop running. So if you're trying to use only one machine, you have to do this thing called local debugging, which lets you view the kernel but not change it. And there's now a GUI for this. You attach to kernel local, and now you'll just examine the kernel on the machine you're using. You can examine loaded modules, and you'll see NT, which is the kernel, and it has symbols. Microsoft makes publicly available all the symbols for this code, which is very nice, so you can refer to alphabetic descriptions of things. And so you can now find all the functions. If you do this LM, it gives you the opportunity to browse full modules or browse all global symbols, and then it breaks them up alphabetically, so you can see all the ones that start with A or B or so on. So you can see exactly how Windows works. You can see all the modules that run it, and so you can find modules. There's some flags to find here. You can unassemble any of the modules. If you want to see NT create file, this is the whole thing. You can see all the assembly code, and all it does is take a data structure and load it bit by bit in memory and then call this other function IOP create file. So it's really a stub to just translate a data structure and call another function. You can search memory for patterns of bytes or text or anything else you like, and find things. You can find strings. This will print out all the strings it finds in regions of memory. You can search for strings and so on. So this gives you the ability to look in the memory. And this means, Microsoft is not open source code, but it's not far from it. Since they give you the symbols and they give you the debugger, you can actually look and see exactly what's going on. So they can't hide anything. And there are a bunch of Microsoft undocumented functions and undocumented switches, and people find them with these tools. It's not that hard to find them. So it's not really hidden how Microsoft works. It just takes a little practice with these tools to see it. So here's what a file is in Microsoft. It's this C++ data structure, and it has a file name, which is a Unicode string, and other parameters, but you can see what it is, and you can see how it's used. You can see all the processes, and you can look at a process and see all the DILs it uses. You can view the devices and the drivers, and it's a lot of good, clean fun. So you can debug a driver. Here you'll be, and this is where, so here's where it gets really exciting though, when you're going to use breakpoints. And I found out you can do this on Azure. You can make 2 Windows 10 machines on Azure, and you can debug one with the other. This network debugging didn't work too well in earlier versions of Windows, but Microsoft has finally got it working very well. So all you do is turn off the firewall, network between the 2 machines, and you set the one machine to debug. So you turn on debugging, and you set the IP address of the other machine that's going to control it. you choose a port number, and you have a key for security. So I use flapjack dog frog, like a password. And then when you reboot that machine, you can debug it from the other one. You attach to the kernel. There's a tab here for net. You give it the port number, the key, and the IP address. And now your target machine can run after you restart it, but it is under remote control of the other machine, which can follow the debugging. And your Ethernet adapter changes into Ethernet kernel debugger, because your Ethernet is now receiving signals from the other machine, which can be used to control it. And if you connect on the other machine, it will first tell you it's busy, it's running. And you can break to cause it to stop running and examine it and execute commands. So you can break it. This will then tell you you've now frozen the other machine. It's going to stop working, but it's not because anything is wrong. It's because you're controlling it from this debugger. And now you can view the loaded modules. You don't have all the symbols, but you can easily load them with a couple commands. And then you'll have all the symbols for all the modules. And now you can put breakpoints in. So you can find a file info command. And I find the best way, if you want to learn about this, is look for the memory handling commands, because those are almost always used. So I found one called file info memset. And if you put a breakpoint in that, or memcopy is another one, then it will hit that frequently. So you define the breakpoints, they show up here, and it will hit immediately because it's always using that function. And you can see the stack, and now you have the whole story. Here's a userland process, then it calls the crypt32 library, the kernel base library, ntdil, and now it does the jump to the kernel. In 64-bit machines, userland all starts with zeros, and kernel land always starts with Fs. So this is the kernel routines in the NT kernel itself, then in FLT manager and file info. So you can see exactly what it does to get in there. And here's the way 64-bit memory is. It has this hole in the middle because you'd only use 48 bits for addressing. And then you can play with this a bit. And the last thing in this section that I want to mention, which is great fun, is here, API Monitor. I put that stuff on Twitter, and Dan Kaminsky said, check out API Monitor. This thing is awesome. It's sort of learn how the Windows API works. And it's been updated for 64-bit systems. You just run this program. You can pick APIs to monitor, like create file. Pick a few create files and monitor them. You click them in the GUI, and now you can load a program like Notepad, and you can see all the API calls you've selected just appearing here. So here's all the calls to those create file, ng create file W. And if you go to one of them, so if you make a file here, like my new file.txt in Notepad, you'll see it here. You see the call, you see the stack, and you see the parameter. And that right there is my new file.txt in the Microsoft 16-bit Unicode with these null bytes in between the bytes. So that's pretty good fun. And so to make a fun project, I hunted around with uses of this, and I found a good one. You can steal passwords with this tool from RDP. When you launch Remote Desktop, it asks you for an IP address and a username and a password, and that's of course done with Windows API calls, and you can catch them. And it turns out that it is crypt protect memory is the call that's used to encrypt the password before sending it off. So you can just monitor it here, and you will be able to steal passwords. Here's the password. So it's another way to understand how Windows works, and those are all quite useful. So I'm going to